Yes, yes, around 20 people joined. Yes, yesterday Anand Modi given some information regarding the current affairs. Anand Modi, today your network issue is resolved.
Yes, sir.
Okay. Yes. What happened in the elections, recent election in US? Joe Biden. Any advantage as we are or as an Indian? Any advantages, job opportunities? Any relaxation over H1N1 visa process? Have you heard about it? Share anything about it?
Sir, as of now, nothing can be confirmed. But the last news that came around H-1B visas and everything, it was made stricter by Trump, and it now job opportunities in the US is strictly limited to computer science graduates. So if you are a mechanical engineer and looking for a job in the United States in the IT sector, it's going to be very tough for you.
Sitash, do you wish to share anything?
Sir, no, sir. My mic was accidentally on.
Oh, oh. Okay, fine. Fine. What was the today's current affair? What was the today's current affair? Anyway. With the current affair, we will start today's session. I think, okay, if there is no updates regarding the current affair, we will start today's session. I request the second five to unmute your mic and please respond me till the end. Else I will no, not second five. I'll request some people. Rangarajan, Rahul, Prithvi, Praveen, and Nishan. Please join with us, Nishan. Please, Rangarajan, Rahul, Prithvi, Praveen Raj, unmute your mic and please be with us till the end. Yesterday we have seen the Lagrange's interpolation. Yes, please join with us. Lagrange's interpolation, the problems with the Lagrange's. Around we have solved four different problems in Lagrange interpolation, and three with forward interpolation, one with inverse, and we have introduced, we have derived the Newton's forward interpolation formula. With these slides, we have seen derivations. Yes, this is the final difference formula. We have started the derivation over the Newton's forward interpolation, and these are the slides for the Newton's forward interpolation formula. And see, uh, this is what we have concluded yesterday. And now you please make a note that Newton's forward interpolation formula, and we are already aware about the delta y. Delta y naught is equal to y1 minus y naught. That is y1 is equal to, therefore from that y1 is equal to delta y naught plus y naught. I am taking the common terminology out from the above equation, and then I am getting a coefficient called 1 plus delta, and for delta 1, aid of y2 minus y1, uh, and therefore from that y2 is equal to y1 plus delta ym. Similarly, as we did in the last step, I'm taking the coefficient, the common term out, and y1 left, and we are getting the coefficient as 1 plus delta, and I am applying the y1 value. Therefore, I am getting as coefficient as 1 plus delta the whole square and y naught. Similarly, for delta y2, 1 plus delta the whole power 3 into y naught, and by generalizing the above information, we will get yn is equal to 1 plus delta power n, and why not? And with this, we can expand. We are already aware about the binomial theorem. We are already familiar with 1 plus delta of our n, and therefore yn is equal to 1 plus n into delta plus n into n minus 1, the second derivative of delta divided by 2 factorial plus n into n minus 1 into n minus 2 into third difference of delta divided by 3 factorial into y naught. Therefore, yn is equal to f of x naught plus n into h. By abbreviating this, y naught plus n into delta y naught plus n into n minus 1 by 2 factorial into second difference of y naught plus n into n minus 1 n minus 2 divided by 3 factorial into third difference of y naught plus and so on. And uh, this is the formula, Newton's formula, or Grigori Newton's forward interpolation formula. Generally it was called as Newton's formula, Newton's forward interpolation formula. And there are two notes we need to remember. Once we are familiar with the formula, then I'll introduce the various notes. We need to remember two notes, and I'll introduce a little later what was the information given in note. Will discuss a little later. And please make it that this is problem number exercise number 5. Find the missing y x from the first difference provided yx and beta yx 0 0 hyphen hyphen 7 and a hyphen 11. Please make a note. Please take your calculator. And we need to identify the missing values. How we can identify the missing values? Do you have any ideas? With the above derivation, we can find. Do you have any idea? Please give some suggestion to find the missing Vx. Rahul?
Yes, I'm working on it.
Okay, what we need to do, we need to assign some terminologies for the missing value. Let the terminologies be A, B, C, D, E, and with that we can find the unknowns. See, this is what let the unknowns be A, B, C, D, E, and therefore the given table becomes yx and delta yx 0 0 and A1, B2, C4, D7, and E11. And by definition, a minus 0 is equal to 1. See here, a minus 1, a minus 0 is equal to 1. And b minus a is equal to 2. See here, a minus 0 is equal to 1, b minus a is equal to 2. My cursor is visible to everyone.
Yes,
Rahul?
sir. Yes, sir.
Yes. Here, C minus B is equal to 4, and D minus C is equal to 7, and E minus D is equal to 11. Once we are aware about A, then we can find the rest. And that was and this is the answer. And therefore A is equal to 1, B is equal to 2 plus A is equal to 3, and C is equal to 4 plus D is equal to 7, and D is equal to 7 plus C, 7 plus 7 is equal to 14, and E is equal to 11 plus D, and 11 plus 14 is equal to 24. Yes. This is your x is number 6. A function f of x is given by the following table. Find f of point 2 by a suitable formula. See here x and f of x values 0, 176, 1, 185, 2, 194, 3, 203, 4, 212, 5, 220, and 6, 229. Here, here what we are going to find is f of point 2. F of point 2. This f of point 2 is very nearer to the initial value, isn't it? That is our note 1. That is our note 1. Here, see what is our note 1. This formula is very useful and gives greater accuracy when x naught plus n into h is nearer to the beginning of the table. When we are in the position to find the value which is at the end, means we need to depend a different formula. That might be Newton's backward interpolation formula, Gregory Newton's backward interpolation formula. If when we are in the position to find the value which is very nearer to the beginning of the table, then at that time we need to depend Newton's forward formula, and accordingly we need to apply Newton's backward formula when the data is at the end. And you note 2, I'll explain. Okay, see here f of point 2 is very nearer to point the beginning value 0, and we whether if we are in the position to find the value of f of 5.5, at that time also we can apply Newton's forward interpolation by, but the Newton's backward interpolation formula is suggested when the data is very nearer to the end. Okay, will we go ahead?
Yes, sir.
Yes. And see, this is the difference table. We need to find the difference table for every problem which is beneath Newton's interpolation. And this is the given x and y value. And this is the difference in y. This is the second difference of y, and third difference of y, fourth difference of y, and fifth difference of y, and sixth difference. When you are having if you are having the n is n, the number of data is equal to 6, then we need to concern about the sixth difference. And here see, 185 minus 176 is 9, 194 minus 185 is also 9, 203 minus 184 is equal to 9, 212 minus 203 is equal to 9, 220 minus 212 is equal to 8, 229 minus 220 is equal to 9. This is the first difference. Similarly, the second difference, 0, 0, 0, here minus 1 and 1. The third difference, 0, 0, minus 1, 2. This is something different than the past studies. We need to write the difference at the center of these two values. See here, we need to write 9 at the center of 185 and 176. And accordingly, we need to write these subsequent data. And here, at the mid of 9 and 9, I have returned 0. Similarly, at the mid of this 2, I have returned this 0. Therefore, the second difference might be 0, 0, 0, minus 1, and 1. And the third difference, 0, 0, minus 1, minus 0 will become minus 1. 1, minus of minus 1 become plus 1, therefore 2. The fourth difference, 0, minus 1, 3. The fifth difference, minus 1, 4. And the last difference, that is sixth difference, is 4 minus of minus 1, 5. And with these data we can apply the information with the Newton's forward interpolation formula. And see here, the initial x is 0 and the difference over the x is h is equal to 1. Here see the difference over the h, and be aware that the x has equal intervals. When we have in some problem they won't give the solution method. We need to identify the method belongs to Newton's forward interpolation or Newton's backward interpolation, or we need to find whether it is belongs to Lagrange's interpolation. When we have the data, whether it may be x or y, when it is equal interval, at that time we need to depend Newton's interpolation. When it is not it is in unequal interval, at that time we need to depend Lagrange's interpolation. And therefore here h is equal to 1, y naught is equal to 176, that is our f of x, and we are going to find the value of f of 0.2. And therefore Newton's forward interpolation formula is, and f of x naught plus n into h is equal to y naught plus n into delta y plus n into n minus 1 divided by 2 factorial into delta second derivative second difference of y naught plus and so on. And here f of 0.2 we are going to find, and instead of x naught plus n into h, I am going to apply the required value, that is f of 0.2. Instead of x naught plus n into h, that is equal to 0.2. X naught, we have the x naught value is 0, n we are going to find the value of n, and h we have the interval is 1, and RHS we have RHS is equal to 0.2. Therefore n is equal to 0.2. I am applying the n value and x naught h y naught value in the Newton's forward interpolation formula. F of 0.2 is equal to 176 plus 0.2 into 9 delta y naught from the table plus zero point 0.2 into 0.2 minus 1 divided by 1 into 2 into 0. Therefore rest I am going to neglect the other terms, because here see, here also I have 0, and here also I have 0 term, here also I have 0 term, and here minus 1. And see, the coefficient which is associated with the fifth difference is what might be the coefficient? 0.2 into 0.2 minus 1 into 0.2 minus 2 into 0.2 minus 3 into 0.2 minus 4 divided by into 0.2 minus 4 divided by 4 factorial. Therefore, I am neglecting such very minimal values. I am keeping this two alone, that is 176 and 1.98, and therefore my f of 0.2 is equal to 177.8. And that and this is the results for this particular problem. And this is exercise number 7. Do you have any doubts with problem number 6?
No, sir.
Okay. Okay. This is exercise number 7. Please make a note. The following table gives the population of a town during the last 6 census, and estimate using Newton's interpolation formula the increase in the population during the period 1946 to 1948, and year, that is 1911, 1921, 1931, 41, 51, 61, and population in the town in thousands: 12, 13, 20, 27, 39, and 52. And see here, what we need to find: the increase in the population during the period 1946 and 1948. And see here 1948, it seems 1943, but it won't be 1943, it is 1948. How we can find the increase in population during 1946 and 1948? Any ideas for finding the solution?
We will use the 1941 data.
Yes, we have 1941 data. Then go ahead.
Yes, sir, then same way we'll find the difference for each of them, and then x naught will be 1948. Sorry, x naught will be 1941 and h will be 1. So we'll find out n in that way, which will be 7.
No. We need to find the value of 1946 first. Then we need to find the value of 1948. Then difference over the year, those 2 years. Yes, see here the difference table. We need to find the difference table first, and this is the difference table. And here, see here y, and the first difference, second difference, third difference, fourth difference, fifth difference of what? The first difference of y naught, y, the second difference of y, and third difference, fourth difference, and fifth difference. And see, 13 minus 12 1, and 20 minus 13 is 7, 27 minus 20 is 7, 39 minus 12, 27 is 12, 52 minus 39 is 13. And see, 7 minus 1 6, 7 minus 7 0, 12 minus 7 is 5, 13 minus 12 is 1, and 0 minus 6 minus 6, 5 minus 0 5, 1 minus 5 4, 5 minus 7 minus 6 plus 6, therefore plus 11, minus 4 minus 5 becomes minus 9, minus 9 minus 11, therefore fifth difference is minus 20. And now uh, here the x naught is equal to 1911, h is equal to 10, and y naught is equal to 12. Newton's formula. We have the Newton's formula. 90, we need to find uh, therefore x naught plus n into h is equal to 1946. When we have the census data, and I have during the fittest outline, I have given one peculiar example. Have you remembered the accident and the example which I have disseminated during the fittest outline syllabus? Anyone can remind and say the information? During fittest outline, I have given one peculiar example. What was the example?
Sir, can you repeat the question?
During fittest outline, I have given one example. What was the example? A real-time example I have asked, and can anyone remind the example? Why the fittest outline is essential? Uh, the I have inquired about the happenings in Kumbh Mela. That was the real-time example which I have disseminated during the fittest item. During Kumbh Mela, one large, very big accident happened during Kumbh Mela due to heavy crowd. That was an accident, and that was a mishappening uh, due to poor administrative ability that was happened. And when we have data, past data, what was the crowd accumulated during the past five Kumbh Melas, then we can predict what will be the expected or predicted amount of persons will assemble during this Kumbh Mela. That has to be done by the administrative, that particular district administrative. Based on that prediction, they need to do the arrangements, whether it may be food or water facility, or it may be a restroom facility or transportation facility, whatever it may be. That was a very big. You can Google it and find the mishappening during the Kumbh Mela. And this is essential. This type of interpolation or an extrapolation or an prediction essential for an management, for an administrative power to do certain actions, isn't it? Okay. See here, x naught plus n into h is equal to 1946. X naught plus n into h is equal to 1946. our x naught is equal to 1911 and n let it be n, and h is equal to 10 and 1946. Therefore 10 n is equal to 35. 35, therefore n is equal to 3.5. And see here, 12 plus what is our 12? 12 is our y naught. Y naught is 12 plus 3.5 into 1, 3.5 into 3.5 minus 1 divided by 1 into 2. Here, this is not 1.2, this is 1 into 2. That is 2 factorial. And similarly, this is 3 factorial, 4 factorial, and 5 factorial. And here into 6 and 3.5 into 3.5 minus 1, 3.5 minus 2 divided by 3 factorial into minus 6. Similarly, 3.5 to 3.5 minus 1, 3.5 minus 2, 3.5 minus 3 divided by 1 into 2 into 3 into 4 into 11, and we have the last one. And please find the answer and tell me. Please find the answer and tell me. Rahul and team. Tell me the answer step by step. We have 12 plus 3.5, and what was the answer for this particular term? Find the answer for this particular term, and 1, 2, third term, fourth, fifth term, and the last sixth term. Please find the answer and tell me. Darshan.
So second part is 43.75.
Second part.
Third part, sorry. Yeah. 3.5 into 3.5 minus 1 upon 1.2 into 6.
No, that is not 1.2. That is 1 into 2. 1 into 2. Others, please. Others, please.
Sir, it is 26.25.
Very good. 26.25. Okay, the fourth term. Fourth term.
Sir, 13 minus 13.125.
Yes, of course. Yes, of course. Yes. The next. No, only two answers. Uh, See, my mentor, that is for doing PhD, the the who is guiding
So
the research
1.604.
called as the guide, and during postdoctoral fellow who is guiding the project called as mentor, and I have acted as an examiner for conducting the examination for my mentor subject. What he did is he asked to show the camera in order to authenticate the examination. Like that, all are what you are doing. You are doing. You are attending. You are giving your presence, and you are. I think you all are sleeping. Only very few only giving your uh, active participations. And what I am planning for the rest of the class, I think it will be better to keep your mic on, sorry, camera on. Okay, tell me the next term answer.
3.00781.
Yes, 3.0078. And for the last,
Sir, 0.546875.
very good. And yes, this is the result. This is the results. And by accumulating the different answers, will get 32.1797. Therefore, the population in the year 1946 is 32.1797 thousand. The data given 1000. Therefore, I'm keeping the suffix as 1000. And similarly, what we need to do, we need to find the value for the year 1948. Therefore, our x naught plus n at h is equal to 1948. The rest are apart from RHM, rest are the same. 1911 plus 10 into 9 n into 10. Therefore, 10n is equal to 7. Therefore, n is equal to 3.7. Yes, and this is the result. Now, for the year 1948, the population is 34.730401, and please calculate the various results. I'll wait. Once you got the results, you got the similar results, then we'll go ahead. Please find please do the calculations and tell me the results. Try to calculate the results for each term and then accumulate. Yes, what was your results?
Sir, similar results, sir.
Okay. Very good, very good.
Yes.
Okay, now we got the population for the year 1940. Already we calculated the results for 1940. Uh, then now we get results. The 1948 is 34 point and the increase during the period 1940. Therefore, increased during 1940. This is exercise number 8. Wages between 60 and 70 rupees, and wages in rupees. Wages in rupees, number of person in thousands. Uh, Below 40 to 50, 40 to 60, 120, 60 to 80, 100, 80 to 100, 70, and 100 to 120 is 70. Please give some ideas to find the results. 60 and 70. Who is earning? Who is the number of persons earning weekly wages between 60 and 70? Okay, the data given for below 40, 40 to 60, and 60 to 80. How we can find uh, the persons earning weekly wages between 60 and 70?
So we'll take the average.
Taking average. Okay, that can also be possible. Okay, now tell me the results. What was the average? with the data? What is the average?
Below 40 it will be 20, for 40 to 60 it will be 50, for 60 to 80 it will be 70, 80 to 100 it will be 90, and 100 to 120 it will be 110.
What is this?
So the x value, and then the fx value remains the same. We basically convert the range to an average value so that we can calculate.
You are divided the entire value with 50.
No,
You derive?
no, sir. Like the for x for values, there's a range, right? Like below 40 or 40 to 60, that way. So we
Okay.
just like do the upper limit plus lower limit divided by 2, that way.
Okay. Okay. But the thing is, below already we have the data for below 40. If you're converting the data below 60, you need to accumulate the data which is available in below 40, isn't it? See here the how we are applying difference the frequency, and this is the difference over the last the problem with the past problem. Here see, below 40, below 60, below 80. When we have the range, then we won't solve. We won't find the solution. We need to convert the range into a number, a numerical. Therefore, I am converting the data 40 to 60 into below 60, below 80, below 100, and below 120. Here the y value is given to 250, 120, 100, 70, and 50. Here the frequency is, here the frequency 250, let it 250. The addition over the 250 and 120 be the values below 60, and the addition over the past with 100 is below 80. The addition over the 70 over the past data is 540, and similarly 590. And this is the frequency that we need to calculate for getting the results in this particular problem. And the first difference is 12370 minus 250 is 120, and here I have given white, but I didn't return the value. 470 minus 370, 100. You please write 100, and 540 minus 470 is 70. 590 minus 540 is 50. The second difference, 100 minus 120 is minus 20. 70 minus 100 is minus 30. And 50 minus 70 is minus 20. And the third difference is minus 30 minus of minus 20 is 10. Minus 20 minus of minus 30 is plus 30, therefore 10. And the fourth difference is 10 minus of minus 10 plus 10, and therefore 20. Here our x naught is 40, and this is what we need. X naught is equal to 40, and h is the difference is 20, and our y naught is 250, and we need to find the value for f of 70, below 70. Therefore x naught plus n into h is equal to 70. And see here, 40 plus n at 20 is equal to 70. 20 into n is equal to 30. 70 minus 40 becomes 30. Therefore, n is equal to 1.5. But I am applying various formula with Newton's forward interpolation formula. F of 70 is equal to 50. This is 1.5 into 120. This 1.5 into 1.5 minus 1 divided by 1 into 2 into minus 20. 1.5 into 1.5 minus 1. 1.5 minus 2 divided by 1 into 2 into 3 into minus 10. And similarly, 1.5 into 1.5 minus 1, 1.5 minus 2, 1.5 minus 3 divided by 4 factorial into 20. And by solving the above information, we'll get 250 plus 180 minus 1.5 plus 0.625 plus 0.468. Therefore, the result is 423.59375. See here, number of person whose wages below 70 is 420, and the number of persons who weekly wages is below 60. Based on the table, the difference table, we got the information 370. That is 250 plus 120. See here, 250 plus 120, who is earning the number of person whose wages below 60 rupees, and therefore the the difference might be the answer. Therefore, 53.59 be the number of persons whose weekly wages between 60 and 70. Any doubts with this particular problem? Any doubt? Any doubt? How I think Bhavya responded. I think so. Here, what we can do by getting the average, whether we can find. We'll check. What was the average for 470 and 470 and 370? Find the average and tell me. 470 plus 370 divided by 2. That is 420. And by subtracting the 420 with minus 370 and 50 be the answer. By calculating the average method, 50,000 be the answer. Isn't it, Bhavya? And see here, what I did. I have calculated the value with the aid of the by average method. I have calculated the 470 and the difference over the 470 and 370 is 100 and divided by 2 will become and 50 by sorry 470 plus 370 divided by 2 is 420 and I am subtracting the 420 with 370. I am getting 50. And but the accurate answer is 53.59375,000. Please make a note this for your practice. Exercise number 9. But I have given the answers to the following table. Give the corresponding value of x and y. Prepare a forward difference table and express y as a function of x. Also obtain y when x is equal to 2.5. The answer is 16.375. This is for your practice. You solve with this exercise number 9 and tell me the results will be next class. And this is what we are going to see during the forthcoming week. The Newton's backward interpolation formula and our y is here. This can be called as del. And in the past forward interpolation we have called as delta. Here del y naught. And instead of negative value we are going to apply a positive value y naught plus n into del y and n into n plus 1 by 2 factorial second difference of y naught and n into n plus 1 plus n plus 2 divided by 3 factorial into third difference of y naught. And this is the formula for Grigori Newton's backward interpolation formula. How we have there are two notes in forward interpolation formula. Similarly, here also we have two notes, and once we are very familiar with the formula, I'll introduce the notes. And do you have any doubts? Do you have any doubts with today's presentation?
No, sir.